Hello everyone, you're welcome to this video. I remain your tutor, Mr. Lifechanger. In this video, I'm going to be showing you the different calculations or the different calculations involving similar triangles, okay? The different cases. There are many of them, up to 10, but I think in this video, I'm going to limit myself to just 5. And so the case 1 is where you have a triangle. Then inside the triangle, you have a line that is parallel to the baseline. This is the baseline. Now this parallel baseline forms a similar triangle. If you notice, they all share equal angle. Both triangles, this is a smaller triangle and this is the bigger triangle. If I call it ABC and maybe call here XY, you can see that triangle ABC is similar. We use this symbol for similar to triangle AXY. So whenever you see a case like this, you always know that you are dealing with similar triangles. Okay. Now, if this is let's say this is A and this is B. Okay. Let's say this is C and this is D, and let's say this is F and this is G, for example. Now remember, from the previous lessons I had, two triangles that are similar, the ratio of their sides are equal. That means the ratio of the smaller triangle to the ratio of the bigger triangle of the corresponding sides are equal. For example, AX here, the side is A, the corresponding side is AB for the bigger triangle, and that AB is small a plus b, is equal to the side here is F, the corresponding side in the bigger triangle is G, equal to the side here, the small side here is C, the corresponding side of the bigger triangle is C plus D. You see that? So once you know this, you can use this to answer any questions that has to do with similar triangle. Okay? And so a good example now is, let's assume I have a triangle just like what I have there, and I have this line parallel forming two similar triangles, and let's say this is 5, okay, and let's say this is 10, and let's say this is 3, and let's call here x, and we are asked to find the value of x. Now, based on what I have explained to us, the ratio of their sides are equal. So here the smaller triangle, the sides of the smaller triangle is 5 and 3. The corresponding side of the bigger triangle is, this is the bigger triangle, is 15, you can see, and x. So I'm going to say 5 over the bigger triangle is 5 plus 10, which is 15, right? Equal to here is 3, and the corresponding side in the bigger triangle is x. So we have x. So this is now 5 over 15 equal to 3 over x. If you cross multiply, you're going to have that x is going to be equal to 15 times 3 divided by 5. And that's going to give you 9. So x is 9. You see that? Very, very easy. Now we could also have a case like this. Let me do one more here. Another example. And here now, parallel to here. And let's say we have here 3 and we have here y. And let's say here is 10 and here is 15. And we are asked to find y. Okay? It's still the same thing. Now remember, you have a small triangle and you have a bigger triangle. Both of them are similar. Similar triangles are not equal, but their angles are the same, and the ratio of their sides are the same. So if we are to solve this now, this will be 3. For the smaller triangle is 3 over the bigger triangle here is 3 plus y, equal to this side for the smaller triangle is 10. The corresponding side of the bigger triangle, this is corresponding to this, is 15. Okay? So I can say 3 over 3 plus y is equal to 10 over, I think 5 can go, that will give us 2 over 3. We can cross multiply. 3 times 3 is 9. Then if this cross multiply, you get 2 into 3 plus y. So 9 is equal to 6 plus 2y. Then you have 9 minus 6 is equal to 2y. 3 is equal to 2y. So we can have that y is equal to 3 over 2. Or you can just simply say 1.5. So y is 1.5. So this is the first case, okay, that involves similar triangle. Now the second case is similar to the first case. I'm going to call that case number 2. This one has to do with two right angles. Two right angles that are similar. So you see a shape like this, and you're told that this is right angle, and you see a parallel line to this, and this is right angle. Now, this is exactly the same thing like we did before, but just that this time around, you are dealing with a right angle triangle. If you notice, there are two similar triangles. There is a smaller one here, and there is a bigger similar triangle here. Okay, so and it's the same thing. Let's assume that here you have W, and here you have X, here you have Y, and here you have Z. And let's say here is R, and here is S. Now you can see that for this, the sides of the smaller triangle is WRY. But the sides of the bigger triangle, the corresponding side here, this one here is W plus X, this one here is S, and this one here is Y plus Z. So the ratio of their sides. That means for this side, I will say W for the smaller triangle all over W plus X for the bigger triangle is equal to R for the smaller triangle over S for the bigger triangle, equal to Y for the smaller triangle, then Y plus Z for the bigger triangle on this side. It makes a lot of sense, right? So if I have, let's say, something like this, it doesn't have to be like this. As a matter of fact, you could see it being placed this way. Now, but once you see a case like this, you know you're dealing with similar triangle. You have a right angle there, you also have a right angle there. You know you are dealing with a similar triangle. You don't need to think twice. And let's assume that this is 2, and let's say this is 10, and let's say this is 4, and we are asked to find X. Now it becomes very easy to find X because already this is looking like case 2. This is already case 2. This is the smaller triangle here. If I should label it, let's say A, B, C, and let's say, let me make here X, Y. You can see that triangle AXY is similar to triangle ABC. A, B, and C, they are similar because they have the same angle. This angle is the same thing here. This angle is the same thing here, and both of them share this angle. You see? Quite easy. So if I should follow the ratio of similar triangle, I would say 4 over the rest is 4 plus X for the bigger triangle, equal to here, the smaller triangle here. For the smaller triangle, this side is 2, but for the corresponding side of the bigger triangle, you can see it is 10. Okay, so I'm going to have 4 over 4 plus X equal to 2 over 10 means 1 over 5, so I can cross multiply. This would be 5 times 4, which is 20, equal to, this is 1 into 4 plus X, and you're going to have 20 to be equal to, this is 4 plus X. X now is going to be 4 crosses to the other side. It becomes 20 minus 4. That is equal to 16. So the value for our X is 16. It is as easy as A, B, C, right? Okay, let me use this to draw another example. Let's say you have this, and this is right angle, this is also right angle. This is another case, like I said. This is the same case here. So, and let's say this is 3. From here to here is 3. We are going to be giving all these things. Let me label them. Let's say this is P, Q, R, then here is S, and here is T. You can see that PS is 3, Q is 2. Then let's say from here to here is 4, and from here to here, let's say, let me call here X, that is unknown. Now this is exactly what we are dealing with. But in this case now, remember, PST, triangle PST is similar to triangle, the bigger triangle is PQR. You see that? So for triangle PST, the smaller side here, it is the side of the smaller angle is 3, the smaller triangle. The corresponding side of the bigger triangle is 3 plus 2, which is 5. Can you see that? Equal to the side here for the smaller triangle is 4. The corresponding side of the bigger triangle, because this is the corresponding side, is 4 plus X. So we can use this to find X. If you cross multiply, you're going to get 3 into 4 plus X is equal to 5 times 4 is 20. I can open the bracket. I'm going to have 12 plus 3x is equal to 20. So 3x is going to be 20 minus 12. So 3x is going to be 20 minus 12 is 8. So x is going to be 8 divided by 3, which can give us, whatever we think. I think 2.67 as the answer to that question. So this is case 2. So whenever you're answering a question and you see a triangle that is this like this, you just rest. You know you are dealing with a similar triangle. But that is not all. I have a lot to give you here, right? So we have a case 3 for similar triangles. Now in this case 3, it looks like this. Watch. When you have two parallel lines like this line is parallel to this line. Please watch. This is parallel to this line. Then you join two ends. This end here joins this end, and this end here joins this end. You form a similar triangle. Yes. And it's very easy. That's because this angle here is equal to this angle here. In mathematics, you know that when two lines cross each other, they form what we call vertically opposite angle. Then this angle here, let me put it this way, is similar to this angle here. It's equal, not just similar, it's equal to this angle here because of alternate angles. Anytime you have two parallel lines and you see a line being drawn this way, okay, you form what we call an alternate angle. So this angle is similar to this. Then this other angle here, I'm drawing using three lines, is similar to this 1, 2, 3. You see? So makes it quite easy. Now, if this is x, for example, and this is y, and this is z, then this is a, this is b, and this is c, you can see that triangle x, y, z is similar to triangle okay, this is not x, y, z, okay, maybe except I make here capital X, and here y, and here z, then maybe make here b and make here c. Okay, so I can say triangle xyz is similar to triangle xbc because this is xbc, but you have to be careful. They are similar, only corresponding sides. So if you notice here, x, this side small x, is corresponding to this big side here, c. They are the corresponding sides. So I can say x over c equal to, for here, y is corresponding to b, because look now, their angles are equal. Can you see? They have the same angle. So y is corresponding to b. So that means this will be y over b. Then for this now, z, for this side now, is corresponding to a. Z of this small angle is corresponding to a because they have the same angle. Can you see? They are both touching the same angle. So I'm going to say z all over a. Okay, so this is exactly what you get. Now, if we have a case like this, let's say I have this, okay, and this is parallel to this. Remember, that's the rule. Don't, and this is a rough sketch. And let's say this is 5, and this is 15, right? And let's say this is 12, and now this is x. Now, and we are asked to find x. Very simple. This 5 here is corresponding to this 15. I would say 5 over 15 is equal to this 12 here is corresponding to this x here. I would say 12 over x. This is even easier than the previous two we've done. And you're going to see that x is going to be equal to 15 times 12 divided by 5. That will give us 36. So the value for x is 36. Very, very simple. Very easy. So this is exactly what case 3 looks like. I hope this makes sense. Then we have another case. It's called case 4. Now in this case 4, it looks like case 1, but the difference is that in case 1 we drew another line that was parallel to this, but this time around it's not going to be parallel. It's going to look like this. You see, it's not parallel. It's a line like this. But at the end of the day, you will notice that this angle here must be equal to this angle here. So if I call here A, B, C, let's say D, E, you'll notice that angle, I can just say angle E. I can call here angle E. Angle E is equal to angle B, right? So angle E is equal to angle B. Okay, let me make it so that you know 2 lines here. This is equal to this. So once this is achieved, you have 2 triangles here. The first triangle is triangle ADE. It is similar to the bigger triangle is triangle ABC. Can you see that? And now that will now mean that and I already told you that this angle is equal to this angle. Okay, this angle is common to both of them because both of them share this angle. Both this smaller triangle and the bigger triangle share this angle A. Then if this angle is equal to this angle and both of them share the same angle, what it simply means is that this remaining angle here, 1, 2, 3, is similar to this one here, 1, 2, 3 of the bigger triangle. Now this will help you know corresponding sides. Please, this is interesting. Remember, the condition is that this angle here formed here after you cut this is equal to this. Then both of them share this angle. It means that these other 2 angles are equal. This is interesting. And if I should label this now, let's say I have W, X, Y, Z, and let me say R and S, something like that. So now let's see the corresponding sides. This Y here, can you see where Y is in this smaller triangle? In this small triangle, in triangle AD, Y is touching both these 2 and these 2 angles. And so Y, the corresponding angle, the corresponding side of Y in the bigger triangle is this one here, because this one is also facing this and this. You see, it's also touching these 2 angles. That's how you do that. So that means Y over R is proper. Now W is touching this angle 1, 3, 1 and 3 and 3 lines like this. This is W. So the corresponding of the bigger triangle is this one here, is X plus Z, is opposite X over, W for the smaller triangle. For the bigger triangle, touching this angle and this is similar. That means X plus S. Then for X now, you can see what X is touching, 1 and 2. That's 1 line and 2, curve here. So X is similar to, let's see the bigger triangle. Which one is touching 1 line and 2 curve? That means is the bigger triangle is W plus Z. So over W plus Z. Now I know that many of you are new to this, but you see, I just gave you a trick. So whenever you see something like this, it is the same. It is similar triangle. When you see a triangle and you see maybe something like this, maybe, and you are told that, let's say this is P, Q, R, S, T, right? And you are told that this angle S, the angle at S, let's say angle PST is equal to this angle here. Okay, is equal to this angle here. It will always be on the other side of the angle. It can never be this side, because it can't be this side, because if you notice, they cannot even be equal, but it's usually equal to the other angle here. So here now is angle TRQ. That's what we call this angle here, angle TR and Q. Can you see that? So let's say I have here to be 5, right? And I have here to be, let's say, 4. And let's say I have here to be 3, and here is X. We don't know what X is. Now it becomes very easy because I need to know the corresponding sides. And like I said, both of them are sharing this angle, right? Both of them are sharing this. This angle here is common to this small triangle here. We can say that triangle PST is similar to triangle PQR, right? And so you are going to have that this side now, PS for the small triangle, let's see, is similar to PS, which is this 5 here, is similar to this 2 and 1, you see, similar to this, right? So that means PS, side PS all over PR for the bigger triangle is equal to this other one now, which is PT. Okay, PT will be similar to the other bigger side here, which is PQ. So PS here is 5 over, it will be similar to this other side, 3 plus X. So kindly just note this, right? Then equal to, here now is going to be 3 all over what is similar is this, which is 5 plus 4. This is how to go about this. This is how to go about this. So I'm going to come here now. This is going to be 5 over 3 plus x is equal to 3 over 9. And I can say 5 over 3 plus x. 3 over 9 is 1 over 3. If I cross multiply, 3 times 5 is 15. And 3 plus x times 1 is still 3 plus x. So your x is going to be 15 minus 3, which is equal to 12. Ta-da! See that? Quite interesting. So this is another case for similar triangles, right? Yeah, this is what to do here. Now we have one more case for similar triangle that's, that is very, very examinable. Case 5. Remember I told you that there are many cases, it's even up to 10. But I'm going to limit myself to the 5 cases. Now, this one is when you have 3 right angle triangles inside one triangle. Okay, now look at this. Let's assume that this is a right angle triangle. This is a right angle triangle. Let me draw it to look better. Okay, so let's say this is a right angle triangle like this, and this is right angle. Then from this right angle, you divide these 2 lines perpendicularly. That means you draw a straight line and divide these 2 lines perpendicularly to form another right angle here. Okay, so I'm going to call here D, right? And let me call here H, the height. Call here A, call here B. Let me call here small letter C and small letter D, okay? Now, this is also a case of similar triangle. You can say that triangle ABC, which is the bigger triangle, is similar to triangle ABD, right? Which is also similar to triangle BDC, okay? So the 3 triangles are similar. Now, but you need to be very conscious of the sides. For example, look at A now. If I take A now and C, for example, A over C, okay, let me use AD over AB. Remember that AD is for this small triangle ABD, and this is the hypotenuse of this. So it is similar to the bigger triangle, right? Now, the hypotenuse of the bigger triangle is this, which is AC. So I'm going to write AC like this, right? No, sorry, it's supposed to be, let me clean this, yeah. So coming back here, remember that AD is here over the hypotenuse. So the AD for this bigger triangle, right, is the same thing as this AB. What this AD is for this angle is exactly what AB is for the bigger triangle, okay? That means this angle here, whenever you have something like this, this angle here is similar to this angle here, which is for the bigger triangle, right? I want you to note these things. And that same way, this angle here, let me call here 1, 2, 3, is similar to this angle here, 1, 2, 3, right? And each of them are sharing this. So it's very important that you be able to. So if I say AD is between these 3 and a right angle. So for the bigger triangle now, between the bigger triangle is this and the right angle, that's C, so which is AB, right? All over the hypotenuse of the bigger triangle is this, which is AC. So at the end of the day, you will notice that AB, if you cross multiply, you're going to have AB squared is equal to AD times AC. And this is very important for you to note. Extremely very important for you to note. So anytime AB is AB, where is it? Okay, that means C squared will be equal to AD, which is A squared times AC. AC is A plus B, so it's going to be like, it's going to be A times A plus B, right? Yeah, that's what you should have here. Very, very important. Yeah, so let's take the other triangle. Look at this triangle now. The same thing here, this B here, or let's say this DC. DC is between right angle and this 2. This one here that has this angle. So the hypotenuse for this is BC. That's the hypotenuse for this triangle BDC is BC. Now, and it is equal to, for the bigger triangle now, this and its right angle, that's this, which is BC. Okay, that's the adjacent for this, or opposite, whichever. Then the hypotenuse for this is also AC. Okay, so if you cross multiply, what it simply means is that BC squared, please note this, BC squared is equal to DC times AC. So this is another rule you should know. So your BC is D. So I'm going to say D squared, that's the, for this D squared is equal to your DC, okay, is going to be equal to B times your AC. Your AC is also A plus B. Kindly note this. This is very important. Then there's something again I like to say. Look at this guy here, H. You know, we can use this. This H now is between this H. We can use it for both the smaller triangle. We can use it for the bigger triangle. So whichever. Maybe we should compare these two. This H is similar to both of them, but for this triangle here, you know there are two triangles here, triangle 1 and triangle 2. For this triangle here, H is between this and these 3 dots here. Okay, so I'm going to have H over, now this is the adjacent here, so we are going to call this angle opposite. So here, for this is between this right angle and this double line here. Okay, so that means H over B equal to, now this, the side in this other triangle that is between right angle and the double line, is actually H. The right angle and the triple line is A. So that means A will be up here and H will be down here. Can you see that? So by the time you cross multiply, you are going to have H squared is equal to A times B. So these are the formulas that you should remember. Or if you like, you say BD squared is equal to AD times AC. Okay, side AC. Now, so what kind of question can we see here? Very simple. I can have this. Once you see a situation like that, this is a right angle, and this now a straight line causing here a right angle. And let's say here is H, here is 5, and here is 6. Or let me say here is 45, something like this. Okay, and so we want to find H. Based on this formula, we can see that H squared is equal to, remember this is the condition, will be equal to 5 times 45 is the rule. So that means H squared is equal to 200 plus 25, 225. That means H is going to be equal to square root of 225, which is equal to 15. So H is definitely 15. If this was meters, it means that H is going to be 15 meters. As easy as ABC. This is, don't stress yourself. Okay, look at another one. Let's say I have this. Don't forget the condition. The condition is if you have here, this is a right angle, then a straight line again forming another right angle here. That's the condition. But in this case now, you have here to be, let's say here is 5, and here is x, and here is 4, right? Now this over this. Okay, I'm trying to, let me see again. D squared, okay, B times A. Oh, very good. So and now we are asked to find x in this case. So you can see these are adjacent sides of the bigger triangle. Okay, please note these are the only ways question can come out. I will show you everything. So these are the adjacent side of the bigger triangle. So in this case now, it's going to be that 5 squared is going to be equal to this from here to here, which is x, then multiply to from here to here, which is x plus 4. That's how to go about this. As easy as that. So that means this is going to be 25 is equal to x into x plus 4. That means 25 is equal to x squared plus 4x. That means x squared plus 4x minus 25 equal to 0. you can now solve maybe using formula method, minus b plus or minus square root of b squared minus 4ac over 2a. I'm not going to go into that, you know. You can use this to solve for x. If you want to, okay, maybe I should. A is 1, b is 4, and c is negative 25. So it's going to be minus 4 plus or minus square root of b squared is 4 squared, okay, minus 4ac. That means 4 times your a is 1, your c is negative 25, divided by 2a. 2a is 1. So that would be minus 4 plus or minus square root of, this is 16 plus 100, all over 2. This is negative 4 plus or minus square root of 116 divided by 2. So I think I have my calculator here to check what square root of 102 is. What square root of 116 is. So the square root of 116 is 10.77. So this is going to be minus 4 plus or minus 10.77 divided by 2. Okay? So that means that I'm going to pick the positive value. X can be minus 4 plus 10.77 over 2. And x can also be minus 4 minus 10.77 over 2. So that would be, permit me, minus 4 plus 10.77 divided by 2. Okay, this is giving me 3.385. That's the first answer. Then the other one is negative here, minus 10.77. This is giving me minus 3.385. Okay, so we are going to pick this as an answer because it is positive. Distance cannot be negative. So that's the answer to this question. So your x here is equal to 3.385. So please, you should notice. So the side is equal to this times the other side. Please do not, the square of this is equal to this times the other side. Then let's do one more. Let's say you have the same thing here, the same thing, and this is this, like this. But this time around, this is what you have. Let's say this is 10, right? And let's say this is 5, and here is x, and we're asked to find x. It's the same thing. I'm going to say the square of 10 squared is equal to 5 times, that's for this side adjacent to it, then times the whole side, which is 5 plus x. Okay, so this is going to be 100 is equal to, this is 25, if you open the bracket, plus 5x. So 100 minus 25, if this crosses the equal sign, is equal to 5x. So 100 minus 25 is 75, equal to 5x. So if I divide both sides by 5, I'm going to have that x is equal to 15. Yeah, so that means x here is 15. So this is exactly all the questions that you need to attend to, or you need to deal with when we are dealing with right angle triangles, okay, similar triangles, sorry. So I've shown you case 1, case 2, case 3, case 4, case 5. So that will be it for today. Thank you very much. Please don't forget to subscribe to our channel. Okay, thank you. Bye.